Hello, so in this video we will talk about order statistics. So what does it mean? What it means is that if we have a group of random variables which are IID for the sake of simplification of the proof. So um, so what does it mean? Let's suppose we have a group of random variables which are independent and identically distributed, and they are arranged in such a way that the first one is the minimum and the last one is the maximum, and they are in ascending order. Okay, so now we are interested in the PDF of somewhere here, right? So the nth random variable, so which is we are interested in the PDF of that. Now note that this is a generalization of something we did in the past, in which we have two random variables. So this is my n, and then we check the CDF and PDF of the minimum or maximum. Okay, so for minimum our n should be 1, and for maximum our n should be 2. So this is for minimum, this is for maximum. Okay, so then this is the generalization of that concept. Okay, now we have n random variables, can be any number, any natural number, and we can have we are interested in finding the PDF of any one of them, which are arranged in some order. Okay, so now what we want to prove is this expression. Okay, so now what is fx? So we should say their PDF is fx of x, and then their CDF is again fx of x. This is small, this is lowercase x. All right. Okay, so in order to prove this thing, what we will use is we will make use of these identities, which are easily proved by using the definition of n choose k. So we start with the CDF of the nth of this variable. So let's say this is the real number 9. Okay, and then we have, let's say this is my x1, this is my x2, this is my x3, somewhere here is my xn, and this is my xn capital. Okay, now we are saying that we are interested in the probability of xn less than x. Okay, or in other words, this x lowercase x is greater than xn. So this means, let's say this is my xn plus 1, this is my xn plus 2, and so on. My region A1, A2, and up to this is my last region. So let's say this is my AK. Okay, so I'm going to say that this is equal to probability that X is a member of the set A1 union probability of X, small x, sorry, is a member of set A2 union up to AK. So what does it mean? X is in A1. This means that exactly n of these variables are less than x. So we will say probability exactly n random variables are less than x union exactly n plus 1 of these variables are less than x union up to the last one, in which say probability of exactly, and x can be actually here as well. So this should be AK plus 1, and then I should say probability x, because x can be anyone, right? X can be anywhere. So exactly n of these variables, random variables, are less than x. Okay, this is random variables. RV means random variables. Okay, so what does this mean? exactly n of them are less than x. So this means we have n random variables and we have some number. We are checking where n of them are less than this. So all we have to do is what? We will say this is equal to n choose n, right? And probability of xn less than x to the n, and 1 minus probability of xn less than x n minus n. Correct? And if you want, you can put an equal sign here. Okay, you can also put an equal sign here. This is not important for now, but then we can say that this is n plus 1. The only thing will change is n plus 1 here, n plus 1 here, and n plus 1 here, and up to this n here. So all I can say is that this whole thing, this is equal to the summation of k, this is equal to n to n, then n k, and then here this guy I can say f of x, yeah, CDF, right? And this guy I can say 1 minus f of x, correct? So now I can say fx of x to the n, to the k, sorry, and then 1 minus fx x n minus k. Okay, so this is what? This is the CDF of the nth of them. Okay, now we are interested in the PDF. So what do we do for the PDF? So PDF of this guy, this is equal to the differential of this, correct? Now differential, for the differential, what we do? We use the product rule. So we will have two components here. So let's keep this guy first and differentiate this guy and see what we get. So we have k is equal to n to n, and n choose k. We say k fx of x k minus 1, and chain rule fx of x, and then this guy is as it is, 1 minus fx n minus k, then plus. Again we will say and choose k. Okay. Then this guy is as it is, the first term is as it is, second term is n minus k, 1 minus fx of x n minus k minus 1 times minus of fx, because of this minus here. Okay, so here I will make use of these two things here. Okay, so then k times this becomes n minus 1, k minus 1, and n here. Okay, and then I have k is equal to n to n fx of x k minus 1, and then f of x, and then 1 minus f of x n minus k, and then I will say this minus, I can say minus here, and I can say k is equal to n, and the second tool I have to use n minus k times n choose k. I'll say n minus 1 k f of x and f of x k, and then 1 minus f of x n minus k minus 1. Okay, alright. Now we make a change of variables in the first summation. So m is equal to k minus 1 in first sum. So then this means that, let me write n f of x outside, and this becomes m, this is equal to n minus 1 to n minus 1, and this is n minus 1 to m f of x m, and then 1 minus f of x n minus m minus 1, okay, minus, then again f of x, this is equal to m is equal to n to n minus 1, then we have n here, n minus 1 m here, then we have f of x m here, and then we have 1 minus f of x n minus m minus 1 here. Now note that they both are exactly the same. The only difference is that this starts from n minus 1 and ends at n minus capital N minus 1, and this starts with n and n minus 1. So essentially what this is that this is a n minus 1 plus a n plus up to a n, and then minus this is a n plus a n plus 1 plus up to a n, and this is minus in brackets. Now if you subtract this summation from this summation, you can easily see that everything here cancels out, and I'm only left with the n minus first term. So all I have to do is I have to say this is equal to n f of x, this is f of x n minus 1, and then 1 minus f of x. Now if I put n minus 1 here, then it will be a plus, it will be n minus n plus 1 minus 1, so I will just say n minus n. So this is, and then of course I have this thing, this n should not be there, sorry, and of course I have, so this is exactly what this is. Okay, so this what we have proved is, we have proved for n random variables what happens when we are trying to find the CDF of the nth of them in order, in ascending order. Okay, now let's say example here. So let's say n is equal to 2, and x1 and x2 are what should we say? Okay, uniform in the range of n 0 1. Okay, so what is f of x? F of x is equal to 1. Okay, in this range, of course. Okay, and let me write it. 1 if x is in 0 1, 0 elsewhere. Okay, and what is f of x? This is equal to 0 if x is less than 0, is equal to x if x is in 0 1, and it's 1 if x is greater than 1. Okay, so the minimum of them in that's so then f of x1, this is what, so we have n is equal to 1 here. So then if n is equal to 1, then this goes. So then we'll say f of x1, this is equal to 2. F of x is equal to 2 times f of x, and then this is n minus 1 is n is what? N is 1, so this goes, and n minus 1 is 2 minus 1, so then this is 1 minus f of x, x1. Okay. So all you have to do is, so in this range, in this range, so this means that in the range of 0 and 1, this is equal to 2 times 1 times 1 minus x. This is equal to 2 minus 2x. So if x is between 0 and 1. So, but in this range, for example, if x is less than 0, so if x is less than 0, so this is equal to 0. If x is less, if x is in minus infinity and 0. Okay. And if x is greater than 1, then also it is 0. Okay. So x is and it's also 0. So this is the, so this looks something like this. So 2 minus 2x, so this is my 2, this is my 1. So it looks like this. So this is 1, this is 2. Okay. So you can see that the highest probability is close to 0 and the lowest probability is close to 1, which means that the minimum, there's more possibility that the minimum is close to 0, and there is more probability, there's less probability that minimum is close to 1. Okay, which makes sense, right? And you can see that without going into details, you can actually see that the maximum should look like this. Yeah. Okay, so this is very low probability that the maximum is close to 0, and high probability that maximum is close to 1. Okay, so this is it about the order statistics. The proof of the so-called formula for finding the PDF of any one of the random variables which are arranged in order, and we also did some simple example using uniform random variable. Hope it was easy to understand, and thanks for watching. Hope you liked the video.